Good morning, students. I, Anu, welcome you to the online class of computers, class 7th. So, today we are going to begin with lesson 2, number system. Introduction. A number is made by individual digit. This we have also you are already learned this part also in maths. A number is formed by its individual digit. Now, the value of a digit in a number is determined on three factors. What are those three factors? The value of the digit itself, the position of digit in the number, the base of the number system. What does that basically mean? We already know that a number it is formed by the individual digits, alone digits. And the value of that digit it depends on three factors. What are those? The value of the digit itself, whether it is, suppose we already know that one is greater than, one is less than 2, right? So that depends on its value. The position of digit and the number, at which position the digit is placed, whether it is at ones place, tens place, hundred place, and the base. But in computer we are learning one more thing, that is the base of the number system. It also depends on the base of the number system. So those 2 points, they might be relating, you might be able to relate them with your maths, but the third point is important here in computer. It depends on the base of the number system. Now, so what is the basically decimal number system is the most popular system. Okay, so we generally follow decimal number system. The one which we are using in maths, that is a decimal number system. It has base 10 and it uses digits 0 to 9. So it has base 10 and it uses digits 0 to 9. Now what does a computer do? Which representation does a computer use? So computer uses binary code representation. In the lesson 1 also I've told you, binary code it comprises of two digits, that is 0 and 1. Okay, it comprises of two digits 0 and 1. All the digital computers they stored numbers, letters and other characters in the coded form. So all the digital computers which we are using in our daily life, they store these numbers, letters in the coded form. They have their own language for communication. We have also studied about the generation of languages, machine language, high level language and assembly language in your class 6th. Okay, so the computers have their own language in order to communicate. They cannot understand the normal English language they use. They have their own language, right? So those all the digital computers they store numbers, letters, and other characters in coded form. Okay, so that coded form is the binary code. Okay, so this might be clear to you. Now moving on to the next topic. Number system is a system of reprocessing numbers in various ways. It denotes a group of characters which denote various numerical quantities. So it basically reprocesses the numbers in different manners. Okay. So whatever numbers are given to it, it reprocesses them. Whatever processing has to be done, that is done. And then it denotes a group of characters which denote various numerical quantities. So it is basically indicating a group of characters which itself indicate different numerical quantities. Now in this chapter, we'll study about basically four these different systems. Decimal number system. Base, please always remember that the base of decimal number system is 10. Hexadecimal. Hexa means 16. Okay, so it is standing with the base 16. Octal, octopus, right? Octal, you have also studied in math. So octal number system stands with base 8. Binary, that you have already learned, it stands with the base 2, right? Okay, so you should be remembering the base of the individual systems in this chapter. Now, number system again, base. Now, very important, a number system of base n has exactly n digits or symbols. What does that mean? Suppose any number system is there. if the base of that number system is n. If it is 10, suppose if we talk of decimal number system, what is the base of decimal number system we have studied? It is 10. So decimal number system will contain 10 digits. Binary number system, what is the base? The base is 2. So the binary number system will contain 2 digits. Octal number system, base is 8. So it will contain 8 digits. So the base of the system defines how many digits can be contained in that system. Hexadecimal system, that is 16. So it will contain 16 digits. Now in case of decimal number system, the number of digits are 10. So it starts from 0 to 9. Binary number system, it has only 2 digits. So it uses 0 and 1. Octal number system, it uses 8 digits. So 0 to 7. And hexadecimal 16. So 0 to 9 is a normal digit. Then after that for 10 we use A. Then for 11 B, 12 C, D is 13, then E is 14 and F is 15. Okay, so 0 to 9, 10 and 10 plus 6, 16. So total number of digits are 16 in case of hexadecimal system. Now let us move forward. Very important, conversion of binary into decimal number system. How we can convert any of the binary number into decimal number system? Children, this is very important from exam point of view, and purely these type of questions are going to come in your UT syllabus. Okay, so these questions are very important. So how, now let us learn how we can convert any of the binary number into decimal number system. It could be any length. It could be any length of digits. We can convert it into decimal. Now here I have shown one example. That is, the binary number is given since the base is 2. We can recognize, see, in case of decimal number system, no base is written. So we automatically understand the base is 10 and it is a decimal number system. But while in all the other cases, whether it is octal, hexadecimal or binary, we have to write the base in order to indicate the type of system. But in case of decimal, there is no need to write the base. While in all the other systems, we have to write the base. So here we have 1 1 0 0 1 with base 2. Base 2 means it is a binary, and already we know that 0 1 0 1 they are used only in binary. So now how we can convert? See. So we are going to begin from the right end of the number, given binary number. We are going to begin with the right end. So I have taken the first number, that is 1. 1 into 2 raised to 0. Okay, we'll begin with the power. We'll multiply with 2 to the powers. Okay, the concerned number would be multiplied 2 with the power. Now the power first, it will begin with 0. So 1 into 2 raised to 0. Now in maths we have studied any number in power and exponents, that any number raised to the power 0, answer is always 1. It could be any number, whether it is positive, negative. If it has a power 0, the answer is 1. So 1 into 1, what is the answer? Answer will be 1. Right? I have mentioned in the bracket 2 raised to 0 is equal to 1. So 1 into 1 is 1. That you already know. Then we have taken 0, right? 0 into, now the power of 2 will increase. So 0 into 2 raised to 1. Now you already know whenever you multiply any number with 0, answer would be 0. So answer has come 0. And third, again we have taken 0, now 2 raised to 2. So answer would be 0. Fourth is 1 into 2 raised to 3. 2 raised to 3 means 2 into 2 into 2. That is 1 into 8. So answer becomes 8. And last is 1 into 2 raised to 4. So 2 raised to 4 is again 2 into 2 into 2 into 2. That is 16. Now, after, in order to find the decimal equivalent of the given binary number, whatever answers we have got, that we are going to add up. So 1 plus 0 plus 0 plus 8 plus 16 is equal to 25. That means 25 is the decimal equivalent of the binary number, of the given binary number. Likewise, we can find for any binary number that is given to us, same approach is used. Okay, every time we have to begin with 2 raised to 0, and every time we multiply the other number, the power is going to increase. Now let us move to the next slide. Conversion of hexadecimal to decimal number system. Hexa means base 16. So I've written here base 16, right? And we know that in hexadecimal 16 digits are used 0 to 9 and A to F, right? So F stands for 16 value. Now again here also we are going to begin with right end. Okay. Now instead of, since it is a conversion of hexadecimal to decimal, so we are going to multiply with the power of 16. Okay. In conversion of binary to decimal, we were multiplying with the power of 2, right? But here it is hexadecimal to decimal, so we'll multiply with power of 16. Okay. So we'll begin again with the right hand. 3 into 16 raised to 0. Any number raised by 0 is 1, right? So 3 into 1. So answer comes 3. Now F. F means we need to find out the value for what value F stands in hexadecimal. So that is 15. So 15 into 16 raised to 1. So 16 raised to 1 is 16. So 15 into 16 comes 240. Then last number 2 into 16 square. So 2 into 56. 256. So that becomes 512. Again we are going to add all the values. So that is giving us 755. Right. So what is the decimal equivalent of the given hexadecimal number? 755. It's your wish. In decimal we can avoid the base or we can write also. But generally we avoid. Okay. There's no need to write the base in case of decimal number system. Similarly, we can do for octal. In case of octal, we'll multiply with the power of 8. And similarly, we can do in case of other systems. Okay, got it everyone? So likewise, you can find the conversion of any of the hexadecimal, conversion of binary, or conversion of octal to decimal number system. In case of octal, you are going to multiply with the powers of 8. Okay, so this is very important. You should be knowing how to do. Moving on to the next topic, binary addition. Now, following are the rules of the binary addition. How do we add two binary values? So 0 plus 0, answer comes 0. 0 plus 1, like you have in maths, 1. 1 plus 0 is equal to 1. But 1 plus 1, the answer would be 0 with the carry of 1. This is most important. Other three rules are same like that you are following in math. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. And 1 plus 1 is equal to 0. Okay. Now just see, I have shown you here the example how to add two binary numbers. We have 1 0 1 0 1 and 1 0 1 0. Now let us see. Begin again with the right hand. You already know the addition also. We begin with the right hand. So 1 plus 0 is 1. You can look up 1 plus 0 because it is new to you. So it is going to take time for you to remember. So 1 plus 0 is 1, right? 0 plus 1, 1. Very good. Then 1 plus 0, again 1. 0 plus 1, 1. And 1 is equal to 1. Now you might be thinking why I have written 21, 10 and 31. So these are the decimal equivalent of the binary numbers. In order to cross check your answer whether you have got the answer correct or not, you can cross check by finding the decimal equivalent of these binary numbers if you have time in your exam. Then you can utilize that time in cross checking your answer. But if you are too sure and if you remember the rules, then there is no need to check. But if you think that you are at a point that you can commit mistake, so you can recheck your answer by finding the decimal equivalent of the given binary number. So here I have already found that is 21, 10 and 31. 21 plus 10 is 31. So that is the desired answer. Okay. So please remember these rules. Rest all is same. All you need to remember is 1 plus 1 is equal to 0 with carry 1. That is the important thing to remember. Moving on to the topic. More on binary addition. I've shared one more example. Like here. See. 111 and 101. So 1 plus 1 would be, what would the answer? 0. Carry I have indicated in red. So that is 1. Right? Got it everyone? So 1 plus 1 is 0 with carry 1. So 1 is carried there. and 1 plus 1 again 0, carry 1. And whenever there are ones, 3 ones together, you should remember answer would also be 1 and carry would also be 1. So 3 ones at the left end, so that gives the answer 1 with the carry 1. Again, see, I've make you understand how you can take the answer. See, 1 1 1 1 1 1, it stands for how we are going to start with the right end. So 1 into 2 raised to power 0 plus 1 into 2 raised to power 1 plus 1 into 2 raised to power 2. So that gives us 7. And next is 5. 7 plus 5, answer is 12. So this is how you can check your answer even if you are not too sure that, or you don't remember the rule properly, or there's a point of any confusion. You can cross check your answer by finding the decimal equivalent of the given binary number. Remember that 3 ones together, answer is 1 with the carry 1. So let us begin with binary multiplication. Following are the rules of the binary multiplication. 1 into 1 is equal to 1. 1 into 0 is equal to 0. 0 into 0 is equal to 0. 0 into 1 is equals to 0. Like that, it is same like that we are following in case of maths. Okay, so any number that is multiplied with 1, so answer is 1. Any number you multiply with 0, answer is 0. So 1 into 1 is same. Okay, so now I have shared one example here, 1010 into 101. Now here just you see 1 into 0 is 0, 1 into 1 is 1, then 1 into 0 is 0, then 1 into 1 is 1. Second step, 0 if you are going to multiply 0 with 0 0, 0 into 1 0, 0 into 0 0, and 0 into 1 0. Again, then 1 into 0 is 0, 1 into 1 is 1, and 1 into 0 is 0, 1 into 1 is 1. Now while similarly while adding, like you are doing in case of normal multiplication and maths, while adding here we are going to follow the rules of binary addition. So when you are going to add 0, it will come 0, 1 plus 0 is 1. All three zeros will will give 0. 1 plus 1 is going to be 0 with the carry 1. Carry I have not yet mentioned here, so please see to that. There would be a carry, 1 plus 1 is 0 with the carry 1, and then again 1 and again 1. So that is how you can solve the binary multiplication. More example we can see 1 into 1 into 1, 111 into 101, right? So again you are going to multiply 1 when we are going to multiply with all the 3 ones, answer would be 111, then 0 with all the 3 ones 0 0 0, then 111. Again we are going to add with the rules of the binary addition, right? So 1 will give 1, 1 plus 0 will give 1, 1 plus 1 will give 0 with carry 1, again 1 plus 1 will give 0 with carry 1, and 1 plus 1 will give 0 with carry 1. So in binary multiplication, we have to follow the rules of binary addition as well as the rules of binary multiplication. That way, while multiplying, you will follow the rules of binary multiplication, and then you will follow the rules of binary addition. Now, what's to remember? Binary code. What is binary code? Computer uses binary code representations in which every character is represented by a string of zeros and ones. So the computer is using binary code representation in which every character is represented by a string. String means sequence of zeros and ones. Base. Base, it refers to a number on which a system of counting is built up. Okay, so it refers to that number. It is a base, foundation of any of the system on which the base of the counting is, on which the foundation of the counting is built up. Okay, on which the system of counting is built. For example, 10 is the base in case of decimal number system, and 2 is the base in case of binary number system. Now these are the home assignments which you need to do after going through the following content and understanding it. How is the value of a digit in a number determined? What is the number system? What is the base of a decimal number system? What is the binary code? Name the most popular number system. How do digital computers store number, letters, and other characters? And write the numbers which are used in binary number system. Next, What do you mean by number system? Explain any two systems, number systems. Write short notes on decimal and binary number system. And add the following binary numbers. We have already learned the rule of binary addition. So you need to solve all these questions and see whether you are getting the correct answers or not. Last, again convert binary into decimal numbers. All these have to be converted into, all these binary numbers have to be converted into decimal number system. Then we have to do multiply the following. Okay, so you need to multiply all these binary numbers and get the required answers. So this is your home assignment. Please students, after going through the content properly and clearly, and please do mention your name and your class after you have watched the video in the comment section. Okay, so please do your home assignment and do it really well and be clear with the concept. Thank you.